Greetings and welcome to the Introduction to Astronomy. In this week's Astronomy of Other Cultures, we continue our look at Muslim astronomy, and we'll talk about the astronomer Ibn al-Shatir and look at his contributions to astronomy of this era. So, Ibn al-Shatir lived from 1304 to 1375 and worked on astronomy in the region of Syria. In terms of astronomy, as with a lot of the astronomers here, he improved on the models of Ptolemy, and in fact was able to completely eliminate the equant by adding an additional epicycle. Now you can remember that these could both be of concern, but the biggest concern in many ways was the equant. Equant being that Earth was not exactly at the center, and really the whole idea here was to get things back to having Earth at the center. And we can see here by adding additional epicycles in the image, we can then work on making the predictions that the model will make match with the observations. Now, he also published his book, his catalog, the al-Jadid, that was, again, another catalog and another method of being able to calculate the positions of the planets. So those were the big keys of the time. We were trying to be able to predict the positions of the planets. And that may not be what we think of when we think of modern astronomy, but in this era, the planets in the solar system were the entire universe, because beyond that was just the fixed stars, which were unchanging. Of course, we know that's not the case now, but at the time we didn't see anything out beyond there. We couldn't see galaxies and other objects, so their focus was really on the planets and trying to be able to understand their motions. Now, not only the planets, but also updated the lunar model, and here is an image from part of his work that shows how the model could be updated. The lunar model, trying to make it more accurate. The moon, you might think, be a lot easier because the moon orbits around Earth, which is what we expected at the time. We expected that everything orbited around Earth, so therefore the moon should have a very easy orbit to predict. But that's not the case when you're fixed on circles, because the orbit of the moon is not a circle around the Earth, it's an ellipse. And in order to match that motion for the ellipse, you have to add in epicycles for the lunar motion to make it, to kind of make, using a bunch of circles, to essentially make an ellipse. Now, he also redeveloped the model for solar motion and improved calculations of the distance. And again, by adding this, was able to restore circular motion by putting in epicycles. So be able to get circles centered on Earth by adding additional epicycles. Now, there is a question as to what the influence was between al-Shatir and Copernicus, because when we look at the models in mathematics, they're essentially identical to what Copernicus put forth. Now, remember, al-Shatir's is geocentric. Earth is at the center. Copernicus was heliocentric, with the sun at the center. But in terms of the model, the mathematics was still almost exactly the same, and it's thought that Copernicus may have had access to a translation of his work that made it to Europe in that era, and that may have given him some of the ideas that then carried over into his heliocentric model. So let's go ahead and summarize what we've taken a look at today. And we looked at Ibn al-Shatir, lived from 1304 to 1375, known for his work on astronomy in Syria, and may have influenced Copernicus, as the mathematics are nearly identical between their two models. So that concludes this discussion on Ibn al-Shatir. We'll be back again next week to talk about another astronomer of the Muslim world. So until then, have a great day, everyone, and I will see you in class.